Good morning, everyone. Welcome to this webinar on checking your advanced steel model. My name's Rob Merriman. I'm one of the application engineers within the structures team here at Graitec. I've been basically working in the steelwork and metalwork industry since I've left university. So before I joined Graitec, I worked in 2 subcontract drawing offices for about 7 years. The first one was a architectural metalwork drawing office, and the second one was a structural drawing office. So today's webinar, I've had plenty of real-world practice of checking advanced steel models, so hopefully I can pass on some of that to you guys today. If you do have any questions about today's webinar, anything relating to advanced steel or anything structures, anything in the AC collection, please reach out to us. My email address is on the front screen, and you can download today's presentation as a handout, and it has all of the links and email addresses embedded in there. So today we'll just have a look at the webinars that we've done in the past, and we've got one more coming up in this quarter. So I've done a webinar on the Advanced Steel Project Explorer, and that one has been recorded and uploaded. John Bennett did one on Advanced Steel and Plant 3D. I did one on using Navisworks to plan your steel installation. I've done another recap on the Revit and Advanced Steel integration last week. Today is obviously checking your model to eliminate drawing errors. And then the last one in this quarter is Revit and Advanced Steel workflows for modular buildings and what we can do with that. If you download the handout, any part of that says please see recording, it will take you straight to the link for the recording. The one that's currently been uploaded, if you email marketing@graitec.com, they will get you a link over once it's been uploaded. Okay, so today we are going to look at checking your advanced steel model. So we're going to look at clash checking, steel construction technical checking, model checks, checking for loose parts. Now we're going to use the tools to check what's attached in the workshop, and then finally we're going to look at something that causes quite a lot of people a problem sometimes, is finding rogue welds where you've got 2 assemblies welded together and you can't quite figure out why that's happening. So before we get on with that, what I'd like to do is I would just like to do a quick poll to see what you guys are using as checks at the moment. So I've just launched the poll. If you could all just click on the checking tools that you currently use, I can just get an idea of what people use currently. Okay, so up to 85, nearly everyone has answered. So 70% of you use a clash check, 30% of you 60% of you use model check, but then only 30% of you use the steel construction technical check, the loose part check, and checking what's attached in the workshop. So hopefully what I'll show you today will help you guys out in the future. Okay, so we are going to get straight into it, and we're going to go straight into advanced steel. So we're going to start with the most commonly used one, which is the clash check. So that's on the Home tab. Under this little check-in panel, we have the clash check option. So clash check will just check, obviously, if 2 items are clashing and hitting each other. If you don't have anything selected, it will clash check the whole model. And if you do a selection window, which sometimes people forget about, we can just clash check this one particular area. So I can do a little window around this haunch connection, click the clash check button, and you get your notification panel. Now this is telling me that I have the collision check found no errors. So if you do that for small areas of the model, you will usually find that. What you will normally find though is that if we don't select anything, we clash check the whole model. You see at the bottom it's running a clash check on the entire model, so it'll take a couple of seconds. It's very rare that you'll get an entire model with no clashes. So what will happen, it will take us into, once it's finished, Probably got quite a lot of clashes in here. It will take us into the clash check panel, and it will tell us what is happening. So what you have is we have an identification number. We have the first clashing part, so it will tell you the part number, the section size, and its model roll. What that is clashing with, again, part number, section size, model roll. If you have a not defined, that's because I haven't run any numbering on those particular parts yet. So that's what the not defined means. We have the coordinates of the clash, and then we have the clash volume. Now what this does, even though all the volumes on my one are showing as 0 at the moment, it will order the items from smallest volume to largest volume. So if you're working through a list of clashes, it's best to start with ones higher up the list. And to locate a clash, you simply double click on it, but the best thing to do is to be in a 2D wireframe. So if we click on this, you can see in here, we then get a red highlight or a sort of temporary block that we can actually select, but this will actually show you the clash. So if we look at something that's clashing with the foundation bolts, we can see that my foundation is clashing with the bolts. Now Advanced Steel will also, it won't just double check what's clashing against each other, it also includes tool clearances around bolt heads and nuts. The size of that tool head is set in the management tools under the defaults, but if I do a little window around this area, we can see that I have a small clash. Let me just manipulate my screen round for you guys. That clash might actually be with the root radius, but that is saying that we've got a small clash in there. Maybe if I go to a top view, we'll zoom back in here. So we've got a small clash in there. So what that's saying is actually the tool to put that bolt in will clash with the root radius of the column. So it's not just checking physical clashes; it will actually check the clash around the tool, so that you can actually get the socket around the items. What it will also do, if I clash check this one, we have a look up here, it will also clash check the length of the bolt as well. So if we have a look at this bolt length, I've got a 55mm bolt. It will actually check to check that it can actually physically get that bolt in and out. So at the moment it's saying that the bottom of that bolt is obviously going to be clashing with the bottom of this haunch beam. So we need to either change the bolt spacings or maybe flip the bolts around and invert them. What we can do with clashes, sometimes that's quite minor. Now you might say, well, my site guys will just flip that bolt around and they'll put a spanner around the nut and a spanner around the bolt. And again, on this one where we've got the clashes on this side, you might say, well, we wouldn't use a socket on there, we'll hold the head with a spanner and then that gets round the clash. So what you might want to do is you might want to ignore this clash. Sometimes it's difficult to fix clashes as well, just because of the nature of the way things are modelled, and some things are intended to clash, such as anchors into concrete. So what we can do is we can select the clash, that one in there, and we have a button down here which is ignore object. Now what that does is it won't remove the clash from the clash check, but what it does is it just takes that line out of your in this dialog. So it's just removing those items from the list. I'll do it for all of them just to show you. So I've not fixed the clash. I just say, well, that's fine. My site guys don't need to worry about that clash. It's not going to be an issue. What then happens is if I rerun that clash on that particular area, you'll notice that it's not taken me to the notification tab that says collision check found no errors. It's actually taken me to the clash check tab, but the clash check is blank. So what this is telling me is that the The system has found clashes, but I've overridden the system and chose to ignore those clashes. So if you ever get this, it's not that there's something wrong with the system, it's there are clashes in there, you've removed them from the list is effectively what we've done. Now, if you've accidentally clicked too many clashes, what we can do is we can bring back those clashes. We might want to double check them, or someone else has been working on this model, we want to double check everything. There is a button here to reset ignored objects, and that will just bring those items back into the list. Now what we can do, when I ran the clash check for the entire model, a lot of the problems were the foundations here, the anchor bolts were clashing with the foundations. So sometimes we might want to ignore the entire object. So we might want to say, well, don't consider these footings for clash checking. Now what we could do is we could select the footings using our filters and just turn them off every time and then run a clash check based on a selection window here. That's a bit of a long-winded process. So what we want to say is we actually just want to ignore those footings for every clash check. So I'm going to use the filter to select the footings. I'm going to right click and go to Advanced Properties. And I'm going to go to Behavior, and you can actually untick Use for Collision Check. Now I will put a large warning in here, is that the clash check will completely ignore those objects for collision checks for everything. So if I was to model a beam now, clashing through, running right through that footing, and I do a little clash check around it, it will tell me that it's found no errors, even though that beam is going right through that footing. So you can ignore the whole object, but you have to be very careful if you do that, because obviously that object is not taken into consideration for any other clashes now. So that is clash check from the poll. Again, that's the one you guys use most of the time. What we would say is don't leave your clash check until the end. Clash check as you go along, because what you might find is that, say we modelled this haunch connection, or the one that I modelled over here with all the clashes, because I've put the bolt spacings horizontally, they're too close together. If I didn't clash check it at this point, I wouldn't realise that I've got 12 clashes in there. And if I copy that round the building, let's say I've got 10 columns, that would be 120 clashes. Whereas if I clash checked it the first time I put it on and gone, oh, I've got 12 columns, correct that so that I've got no clashes, then when you copy it round, you're not copying around 12 clashes onto every column. So we would strongly advise and never leaving clash checking until the last thing you do. Always put a connection on, clash check it. Copy it round and clash check all. Say we copied it to the tops of all the columns, clash check all the tops of the columns. Put your mezzanine connections on, then clash check it. You should just be constantly clash checking as you're modelling, because then you don't get to the end and have a list of 500, 600, 700 clashes, because you'll just sit there for hours and it could be one that you've copied round hundreds of times. So that's clash checking. The next one we're going to move on to is underneath it. It's less commonly used. I'm going to show you, but I used to use it on every job that I did. It's called Steel Construction Technical Checking. So if you look at the dialog as I hover over it, it says checks the model on steel construction technical factors. And a lot of the things it's going to pick up would go unnoticed until you were editing drawings, or the workshop were manufacturing it, or you were running NC data. So it looks at design factors such as bolts that are too close to the edge of the material. So if I run this technical check, now we will get quite a lot of errors. I'll explain why we're going to ignore most of them. So the main one we get in here are some objects in the bolt pattern are too close to the object's edge. And you can see in here I've got 65 technical checks. Well, most of these are about bolts in the bolt pattern too close to the object's edge. Now, in the management tools, there are some edge distances to control, some values, sorry, to control the edge distances. It's not quite as simple as 1.5 times the bolt diameter. It is a value. It's a value that we're running tests on to figure out exactly how it's set up and how it's controlled. So what we'll do, once we've got to the bottom of it, we'll write a blog on it. So if you keep an eye on the Graitec Advanced Steel blog, over the next few months, when we figured it exactly what that value changes, we will put in there, we will write a blog on it. The two specific issues that I'm looking for in here are two specific descriptions. So what I'm going to do is I'm going to sort this list based on the description. And it's these top two. Welds do not connect to anything or only connect to one element. So you might have manually put a weld in, but only selected one item. But the definition of a weld is to connect two elements together. So what we can do, again, we'll go to a 2D wireframe. If I double click on that, it will take me to the weld. Now, what I can see in here is I've got a staircase with some balustrade that I've used the balustrade macro to do most of the work, but I've had to put some of my own welds in. So this weld only connects to one object. So when I would come to run my numbering, it wouldn't be one assembly. So what I can do is go to the Objects tab. I don't need to delete the weld and put it back in. I can go to the Objects tab, and I can use this option in here, Add Objects to a Connection. And I can say, right, that's the weld. Right click. What do I want to add to that? I want to add this and this. And that will remove, if I reran my check, that would take that one out. So I've got a couple more in there. Sometimes it's if you put a weld in or you delete a joint box. For example, in here on my balcony frame, I did have a supporting member going across the middle. Maybe my engineer has told me that we're going to stiffen up the outside of the PFC and we don't need the intermediate beams. And I've deleted the beams out but forgot to take that weld out. So we can just go in there and delete that. The other option that we're going to look at, and it's quite difficult to distinguish between the two, but if you look at this line, some bolts in the bolt pattern are too close to the object's edge. The one I'm concerned about is some holes in the hole pattern are outside of the connected object. So if I double click on that, we'll close that down and we'll investigate what's happening with this beam. So just to go back to realistic so you guys can see where it is. It does, when you double click on it, it marks it for you. And these beams are going to have some timber packing going on the top. So my clients asked me to put holes in for the timber packing. Now it's those holes that are outside the object. But what I want to do is, I can't see that at the moment. So I'm going to isolate the beam. And again, I still can't see it because it looks like the holes are fine. What I'm going to do is double click on the beam, go to the display type, and I'm going to change it so that it shows me all of the features. And then when we have a look, we can see that it's okay at this end, but at this end, that pattern of holes is actually going outside of the object, like the steel construction technical check showed me. So what I want to do is I want to fix this before I run the drawings and before I run, most importantly, the NC data. If I ran an NC file for this, it would flash up and give me a warning. But what we want to do is we want to eliminate all of these errors so that I don't have errors in the NC files. And the problem is that these holes are just, the spacing's a little bit big on them. So if I change that to 375 maybe, that'll bring that in on each edge. And then if I run the steel construction technical check on that, just on that one element, it's found no errors. So for steel construction technical check, I use it to show me welds that only connect to one item and any holes that are outside of an object. So we'll just tidy this one up and we'll just turn off a few bits and pieces. Just turn off the joint boxes. So that's steel construction technical checking. The next one we're going to move on to is model checking. So this checks for items within this model that don't make sense to advanced steel. So it's called model check. There are errors with the modeling. So it's not beams clashing through each other. It's not items outside of holes. But if I run this, these are the two sort of most common ones that we will get is that a beam can't be calculated. So what we've got is we've got a shortening, and the shortening value is longer than the actual beam itself, and we have an overlapping shortening. So if we start, well, what we have in model check, if you look down here, is we actually have an option to fix all errors or to fix selected errors. So I'll just double click on this one in here. Now what I've got here, so I put this in deliberately, is I have an advanced steel beam. If I double click on it, it's a 150 by 75 PFC. But if I isolate it, you can actually see that there's nothing going on there. And that's because the model check is telling me that it can't calculate it because I've put a shortening on here that's longer than the beam itself. So what I'm going to do is I'm going to see if Advanced Steel can fix all the errors for me. So it's fixed the overlapping shortening one. So it's removed a shortening that impedes the body calculation, because if I isolate this now, it's still got a lot of shortening on one end. So what I can do is go display type features, and I've got a feature in there that's shortening the beam by quite a lot. So I wouldn't really do that, because your system line is too long and your drawing will look lopsided, because you've got the drawings will always show the system line. But that's if you've got two shortenings that completely remove the entire object. This one cannot be fixed. So beam shortenings are part of a connection. Update the connection. So if I double click on it, what it's doing in here is, in here I have a L-shaped cap plate, and I've shortened this SHS section, and I've used the cutter object command to cut it to the plate. But what I've done accidentally is I've done that cutter object twice, so it's put two cuts in there for me. So what I need to do is go to display type, turn the features on for that column, and you can see that we've got a shortening in here. And if I select that shortening and delete it, you'll see that it has actually left another shortening. That's because I had two shortenings on top of each other. And again, if I ran an NC file for that box section, it would put two lines of code in to cut the beam at that length. So you don't want it to cut that beam twice, you only want it to cut it once. So this is why you would use your model check. So now that I've deleted one of those, we'll run the model check again, and this time its model check has found no errors. So that is model check. So what we're going to do now is we're going to move on to checking whether our model has been assembled correctly. Now most of the time, if we're using, get my graphics back, if we're using a connection in here, like this is a haunch connection, the haunch connection is not going to put the welds on incorrectly. It's not going to leave this haunch beam as a loose item. It's not going to leave that plate as a loose item. What I'm going to show you now is mainly for the stuff that we're going to do manually, or the stuff if we use this features tab where we've got to put notches with welds on and things like that, cutter objects. That's where you can either have a weld or not have a weld, and sometimes you will forget to put the welds on. So what you don't want to happen is you don't want to run all of your fab drawings and you start editing them, or you even send them to the workshop, and you've got a cap plate that was modeled manually and you use cutter object and you've forgotten to tick the weld option in there. You want to pick that error up before it gets to the workshop. So what we're going to start with is we're going to go to the output tab, and there is a button in here that will mark any loose parts. So it searches the entire model and highlights any unconnected parts. That's unconnected in the workshop. So it's found 54 single parts in my model. Now it marks them in red, but what I want to do is I want to isolate them so it's easy to see what's loose and what's not. So I'm going to go to the Selection tab, choose the Select Marked Objects option, and then I'm going to go to my Quick Views and choose Show Only Selected Objects. And then I'm going to clear the marking so I can see what's going on. Now all of the concrete footings, they're going to be loose. So I'll use the filters, select the concrete footings and just turn them off. Now I'm left with certain steel items that is telling me is loose. Now if I look on my staircase, all of my folded plates, I want those to be loose, so that's modelled correctly. This support angle in here should be welded. We'll go and look at this one. So what I've got in here is I've got a PFC for my roller shutter doors, and I've got some angle cleats. So these are all angles. So these should be loose items, so that's fine. And because this PFC has no end plates, because we're using a bolted angle collection, this will be supplied to site loose. So I can select all of those and just turn those off. Now these items in here, I know are part of my PFC frame. Now that PFC frame I want to be a welded lump. So I know there's a problem with those. I know there's a problem with this, and these end caps should be welded. So I'm going to just mark those items. We'll just correct a couple of them because I don't want to keep you guys here all day. So what I'm going to do, we'll start with these end caps. So these end caps, like I said, have been created. I've manually drawn the plate, and then I've used the cutter object command to cut the plate against the box section. So if I go into the joint, the default option for this cutter object is to not create the weld, so that's why they're loose. So if I create the weld in there, and I come into this one, and I create the weld, those will be welded. Now I'll show you another tool for checking those in a second. We'll just correct this balcony frame. Again, for the balcony frame, I've used the parametric notch joint, this one in here. And if we look at the welds, it says to create a weld, so it's welded. So my next question is to be, well, why is that loose? Because if you look at the weld location, the default weld location for this parametric notch joint is to actually put the welds on site. So that's why it's classed as loose, because it's going to be welded on site. But I don't want it to be welded on site. I want this whole frame to be welded and craned in one go. So I need to change these to shop welds. And the same in here, I've got one on either side. So we'll just come in here and we'll go shop. Change that to shop. Now we do have library entries, so you could set one up and call one site and shop, and then you can just, instead of changing it every time, you can just choose the values you want. So again, library entries can save you a lot of time. So I'm just changing all of these to shop welds, and then we'll move on to the next bit, is actually manually checking what's welded together. So if I clear my marking and I just run that loose parts again, I've now dropped to 49. So if we have a quick look at that, clear the marking, we'll turn the footings off. So I don't have anything in this area. I've still got that little bit which I could manually weld, but we're just going to move on for today. But the items in my balcony frame have now been corrected. The next bit we're going to look at is, so what we've done is we've used the tool to mark loose parts. What I want to do before I run my fabrication drawings is check what's attached in the workshop. So I'm going to use this button here. Now this is probably the button that, when I was detailing, is the button that I use most of all in Advanced Steel. It's clear marking and display objects connected in shop. So this balcony frame, I know I want to be one welded lump. So I can click on any part of the balcony frame and right click, and that tool will mark for me. So it's marked in red what's attached in the workshop. So we can see all the end plates go red. And more importantly, all of these trimmer beams have now gone red. So this is now welded, and everything on there will show on the assembly drawings. And I can do the same in here just to double check those cap plates are welded correctly. Now what I would do is, if you're using any of the functions in here, I would always use this clear marking and display objects connected in shop. Again, like the clash checks, I would never leave any of this to the end. Once you finish modeling this balcony frame, I would do a quick show me what's attached in the shop. If I did it on the rafter, because the connection vault puts all the information on, it's never going to do anything wrong. The only time it's going to go wrong is if you're using items in this feature tab, and you can either turn the weld on or off, or it's a site weld, or it's a shop weld. Now what I'm going to show you is I've got the CHS columns that have got welded I-beam stubs and a fin plate, and then we've got an end-to-end splice connection. Now the end-to-end splice and the fin plate and the cap plate connection are all connections taken out of the connection vault. So it's not going to mess up any of the welding on those items. But again, if I check that, choose this plate here, you'll see that the whole column goes red, the cap plate, the fin plate, the stub on the other side. The items that I've manually put in is the contour on this stub, because it's curved to suit the column, and then you can turn the weld on or off in there. So I think it'll be element contour rule to cut that. So because I've done that manually, I would double check each one of these columns. As I have put a deliberate mistake in here. If I choose this column, we can see that this side has not gone red. Now if I do a shop attached on this, what it's actually doing is, because the end-to-end splice will automatically weld this plate to this I-beam, that would go out as one assembly. So that there would go out as one assembly. So it would get maybe galvanized, maybe powder coated. Hopefully your workshop might pick up on it, but if one person was making some bits and one person making other bits, they might assume that's what you've wanted to do. And then that would go out as one assembly. Because I've used a feature to attach the items in here. So what I need to do is I need to figure out what I've done in there. So we'll turn the features on. So it's this circular feature here. We'll go into the joint properties. So I've used element contour rule, but I've forgotten to tick the welding. So that's where I would use clear marking and display objects in shop, because that would have gone as two assemblies. And it should have been picked up by me when I was editing the drawings, hopefully by the guys in the workshop, but it's always best just to use this little checking tool. It's a one click on that. If everything goes red, we know we're all good. So that's clear marking and display objects connected in shop. We've got two more bits to cover. One wasn't in the list, but I'm going to look at assembly weight information. So this balcony frame here, I just want to double check the weight of that assembly and find its center of gravity. Because obviously the center of gravity is not in the middle because of these support beams and the end plates and things like that. It's not just a square frame. So I might need to put that information on the GA drawing or the assembly drawing for when they're going to chain it up to go in. So what we can do is you do the clear marking and display objects connected in shop. We use this red eye here to select the marked objects. And on our home tab, under the checking panel, there is a center of gravity and total weight calculation. So it gives you coordinate values for the center of gravity on your command line, and it gives you your total weight information, but it also gives you a point, and that is the center of gravity of that assembly. Now, I can't automatically get that to go onto a fabrication drawing, but what I can do is put my UCS on the corner of the balcony, and if I type ID to ID a point, I can choose that point in there because that's my node point, and it gives me from the corner of my balcony the X and the Y dimension for the center of gravity. So you can transpose that onto your fabrication drawings if you need the center of gravity on your fabrication drawings. So there's just an extra little sort of tip there for you if you ever need the center of gravity or total weight. Maybe you're doing balustrade panels and you're concerned about the weight because they're being manually handled. That's a very good little tool. There's also, if you click the drop down, just the assembly weight information. So what I'll do, I'm going to isolate my staircase. So if you watch my Project Explorer, I've clicked the wrong button there, I've gone to Model Browser. My webinar that we did, the very first webinar we did on the Project Explorer, I've created a model view for my staircase. So all I have to do is click the model view, and that will isolate my staircase, so it's easier for me to work on. Now what I can do is click the little check-in drop down and go assembly weight information, click that post. It will check everything that's attached, and it tells me the weight of that is 63 kilos. So that should be fine for a couple of guys to get in. The length of it might be a little bit long. The last little bit we're going to look at is rogue welds. So these balustrade panels, most of the work has been done by the macro, but what I've done is I've deleted the macro just to finish off little bits and pieces. And what I'm using is I'm using the clear marking and display objects connected in shop. In fact, what I'll do, I'll do that. I've put a deliberate error in here. So I'm clicking show me what's attached in the workshop to that infill bar. And you'll see that there's a panel down at the bottom that has turned red. Now those panels are obviously not welded together in the workshop. So because I've manually modeled some welds in there, I've brought an error in. And what you don't want to do is you don't want to run your fabrication drawing to find that. Then you have to delete the fabrication drawing, find the error, sort it out, change the numbering, and then rerun the drawing. So again, this is something that I used to do on anything that I've manually modeled. I would check before I actually ran the drawings. So what we need to do is, I'll just turn this off. I've got quite a lot of welds in here. So what I need to do is I need to figure out which weld is causing me the issue. What weld out of all of these welds in here is causing me the grief? And I've got, let's see, is this going to tell me how many welds I've got? I've got 73 welds. So I don't want to check each weld or delete welds, put them all back in. I just need to very quickly figure out which weld is causing me the problem. So in our selection tab, we've been using this clear marking and display objects connected in shop. Well, next to it is a clear marking and display connection means. So this will highlight any bolts or any welds associated with the assemblies and the items that you choose. So what I'm going to do is I'm going to select this panel up here and say clear the marking and display the connection means of this panel. And then you can see that all the welds in here go red. Nothing has gone red on this one. So there are no welds in this panel connecting these elements. So we can repeat the process on the other assembly. And this time, you can just see in there that I've got those two welds in there are actually connecting items in this panel, which is what's causing me the error. Now, I know this because I deliberately put this in. If you can't see those welds, what we can do is we can click this button here, which will search for the marked objects, and then it will give you arrows pointing to the errors. And then what we can do is we can simply go to the Objects tab, and this time I'm going to say delete objects from a connection. So I'm going to say these two welds in here, I want to delete everything from this panel, because those two welds should have nothing to do with these objects over here. Now if I clear my marking and select any of the infill panels on the top panel, you'll notice that only the top panel has gone red now, and if I do the same on the bottom panel, only the bottom panel has gone red. So that's how I would check for rogue welds, and it's always down to, obviously, you guys as detailers. When you're putting your own welds in, you might accidentally have something in the background showing, and you accidentally click on it, and then it's welded two items that are nowhere near each other. And that is all we're going to show for today's webinar. I won't take any more of your time. We'll just, because we've been through everything we were going to cover. So, like I said, thank you very much for joining us today. That's the end of today's webinar. I will keep the webinar running for a couple of minutes in case anyone does have any questions. If it's something I can answer quickly, I will do it now. If not, I get all the questions emailed to me, so I can respond to the emails, and obviously my email address is there on the bottom of the screen. So thank you very much for attending. If anyone does have any questions, please type them into the question box. If not, thank you very much. And we've got one more webinar next week for this quarter. And then if you keep your eyes peeled for the next quarter, we'll be running more webinars. There will be a short survey after this webinar. And if you would like to see any particular topics covered, please let us know. And then hopefully we can tailor some webinars for what you guys want to see. Okay, I've got a question from Mark about the audit button. So the audit button is an AutoCAD function, but it has been expanded for advanced steel elements. So on the Home tab, we have audit. So that evaluates, if you look at it, the integrity of a drawing and corrects some errors if it can. So if I run an audit on here, it says fix any errors detected. We'll say yes. So we'll just let it run and see what it does. Okay, we'll just drag this over here. So it's fixed an error with the transfer map. That usually does come up. What I'm actually interested in is so it looks through the entire object. It looks at AutoCAD elements as well. So it's got in here that it's audited 6 blocks. So those are blocks that you might have had in the model that you've then deleted out. But Advanced Steel and AutoCAD still keep a reference to that element. So if you have thousands of blocks that you've deleted out, still in the background is a reference to those elements. So by auditing or purging, it just clears out all the references to those elements. And in here, if you look, it says it hasn't erased any objects. It's fixed that one error. It will also in here show you that if you've got any duplicate holes on top of each other, and it will try and delete those duplicate holes. So if you've copied something and you've got holes on top of each other, it will say, well, you've got 2 holes exactly the same size in exactly the same place, and it will, if it can delete them, it will delete one of the holes, one of the sets of holes. What I did to set this model up is, for my staircase, I actually pasted the staircase in from a different model, but it had a load of extra stuff with it. So I deleted those objects out. But again, because I've pasted Advanced Steel objects in the background, in the lines of code, it remembers what I pasted in. Even though I've deleted the elements out, there's still a reference to it in the background. So by running the audit, what it will do is it will remove all references to those objects that are no longer deleted. And what we do tend to find on technical support is if we have a model that's causing lots of problems, some people do tend to paste in entire models and delete 90% out to only work on the 10% that they need. And they might then paste another model in and take just 10% of that model. But in the background, it's still referencing each of those 90%. And sometimes we've had audits that have cleared out like 80,000 Advanced Steel elements. So it's usually it's a bit like the AutoCAD purge tool. When you delete things, they are not completely gone. There are still references in the background. So the audit just goes through those references and clears out that kind of information. I don't know if anyone else has any other questions. If you do, if you put them in the question box. If not, we'll close the webinar, and you can email me any questions or reach out to me, and we'll go through it that way. Okay, nothing is popping up no one's popping up with any more questions. So thank you very much for joining me today. Like I said, if you do have any questions relating to Advanced Steel or the AAC collection, you've got all our contact details, so please reach out to us. So thank you very much.